Good afternoon, dear colleagues, and welcome to the second lecture of the AAA online lecture series devoted to the North Pontic region. Before we start, for those who are not familiar with this lecture series yet, some short explanations. The AAA is standing for ARVA, Archaeology in Action, and ARVA is the acronym for the International Association for Archaeological Research in Western and Central Asia, founded on the initiative of Professor Marc Lebeau, who is also its president. Recently, the association included in its program also Southeast Europe and the Pontic region, offering a wide range of talks and discussions about ongoing research in the fields of both archaeology and history over a vast geographical area. An additional benefit of this lecture series is their recording. If you have missed a lecture or you would like to listen to it again in more detail, you can access it via YouTube on the ARVA platform. Our North Pontic lecture series includes 8 lectures that were planned and organized by Dr. Biserka Gajdarska. And Biserka is today out of office and has only a weak internet connection, but she's online now with us and will be hopefully so until the end of the session. It is therefore a pleasure for me to moderate the session today and to welcome and introduce our speaker, Dr. Alexandr Diachenko from Kyiv, also on behalf of Biserka. Alexander, or Sasha, was born in 1982 in Cherkasy, Ukraine, and lived there until he moved to Kyiv to study at the Taras Shevchenko University. He studied archaeology to master's level, graduating in 2004, and then studied for his doctorate at the National Academy of Sciences, Institute of Archaeology, on the topic of Tripolye population of the Southern Bug and Dnieper interfluve, spatio-temporal analysis. He completed his PhD in 2009 and was soon appointed as a researcher in the institute, where he still works today as a senior researcher. His main interests include prehistoric settlement archaeology, mainly for the Neolithic, but also for the late Paleolithic, prehistoric demography and population projection, archaeological theory, and chronology. He has conducted fieldwork mainly in Ukraine, but also in Poland. He is the most prominent modeler working with the Tripilia and Funnelbeaker or Trichterbecher groups today, exploring rank size distribution, the gravity model, and carrying capacity, as well as fractal approaches to settlement distributions. He has worked with many Western colleagues, notably Ezra Zubrov and Johannes Müller, at whose invitation he became an editorial board member for the Journal of Neolithic Archaeology. Sasha has been prominent in developing the information theory-based approach termed anthropology, a blend of the words entropy and anthropology, and has also worked on the history of archaeology and the nation state. He was one of the editors of the Volodymyr Krutz In Memoriam volume and is an advisory editor of the Journal of World Prehistory. Sasha has co-organized several sessions at the annual meetings of the EAA, of which he has been a long-term supporter and member. We are very much looking forward to his talk today, which is entitled Cultural Diversity, Convergence, and Transmission Scales. Sasha, the ARVA screen is now yours.
First of all, I would like to thank the organizers for inviting me to present such a brilliant lecture series. And today I'm happy to discuss some of the results we achieved with 2 really brilliant scholars, Ivona Sapkova-Tabaka from Adam Mickiewicz University in Poznan, Poland, and Rajan Rivers from Imperial College London. This talk briefly summarizes 3 papers published and being submitted, and these papers were written within the framework of the project Dynamics of the Prehistoric Culture, Comprehensive Analysis of Records from Central and Southeastern Europe. a grant from the National Science Center of Poland awarded to Ilona Sapkowicz-Tabak. Since it is not a distinct lecture, but a lecture series, I would like to pick up the topics, ideas, and thoughts raised by Alexei Nikitin in his previous lecture and talk a bit about the current state of archaeological method and theory. In his widely known 2014 paper, Kristian Kristiansen characterized the current state in the theory of our discipline as the third science revolution. Three cornerstones of this revolution, according to Kristiansen, are the big data analysis, modeling, and new fields of retheorizing. Big data, of course, includes incoming data from natural sciences. By the last year, the term third science revolution seemed to switch a bit to the term archaeogenetic revolution, defining culture history as a major explanatory framework in the discipline, increase in archaeological data, which is a good news for all of us, meaning that it's a little bit early to start searching for another job, and at the same time, a significant inflow of science data will, in fact, somehow dominating archaeological data in terms of our understanding of world prehistory. So the good question to ask is, what is the current place of archaeological data among the other evidence in the knowledge structure? Archaeogenetic revolution to some extent shifted the discipline to what may be roughly labeled as Cassino's legacy. There is a great number of quite good papers written in this respect, exemplified it by Walker Hayes' great article, Cassino's Smile. So basically, the idea is, roughly speaking, when you have newcomers at your site, and this corresponds in time with the appearance of some artifacts coming from the same area where newcomers from, you would probably expect migration and some foreigners' contribution to local cultural diversity. Of course, there are some concerns to this approach, such as correlation and causation in terms of ignorance to convergence, the question of transmission scales, if we do not discuss massive migration, but instead discuss some interactions, exchange in marital patterns, and so on. But generally, the explanatory framework is quite solid. The only problem, it tells us only a part of a story of the past. Once again, returning to the previous talk by Alexei Nikitin, last week, one of the most important results presented to us was correspondence in time of continuous genetic flow and significant cultural transformation. So taking Cassini's legacy as a starting point, we would probably expect significant change in genes, which Professor Nikitin doesn't observe. Moreover, mobility patterns, network structures, and so on, everything dealing with mobility, migration, interactions, good frameworks for explaining the spread of innovations, but weak in explaining their origin. So we should search for the other parts of this story, and this brings us to what may be roughly labeled as child's legacy. Unlike in Cassini's legacy, where we emphasize vertical transmission, demic diffusion, and to an extent horizontal cultural transmission, child's legacy would emphasize local innovations in response to environmental, economic, and social context. And not only innovations, but also selection, withdrawal of certain cultural traits from the set. This also sounds quite reasonable and exemplified by very good examples. One of my favorite is represented by several papers written by Detlef Gronenborn and his collaborators. Basically, what they discovered are the cycles of rises and falls in the diversity of the LBK stylistic motifs in Germany, which serve as a very good proxy for social dynamics and conflict. In this case, we are probably rather looking at change than at stable situation. But the trick is that culture changes even in case of socio-politic and economic stability. Simply saying nobody of us needs a new government to replace blue jeans by black jeans. It simply means nothing. It's not a proxy. However, to what extent do we remember this working with archaeological data? Daniel Kahneman provided a number of exciting examples when even people quite familiar with statistics and even professionally trained in statistics somehow tend to search for patterns, link different things together, even if there are no actual links between them. And this is something about us as human beings we should not forget about. Returning to blue and black jeans and cultural changes or stylistic changes, which can't be served for a social or political proxies, we can archaeologically exemplify this by the quite similar pattern to what Detlef and colleagues got, meaning the rise and fall in diversity of Western tripolar culture pottery shapes in central Ukraine. So, considering all these advantages and issues, the question of what is the current place of archaeological data in the knowledge structure can be paraphrased to what archaeological data and human culture in general are all about, which brings us to the well-known spaces of formation process and quality of archaeological record, the issues intensively considered in the framework of behavioral archaeology, Darwinian archaeology, studying macroarchaeological patterns and complexity in archaeology. The next question is uncertainty the most general property of archaeological record? Two experts in theoretical physics, Tim Evans and Ray John Rivers, spent enough years working with archaeologists to positively reply this question, suggesting the term anthropology, basically linking together entropy as a measure of systems uncertainty and anthropology. Leaving this self-irony aside, the term in fact refers to the information theory, which usefulness we will discuss in the next few minutes. Just a very short point, advertising colleagues to look at Ray and Tim's papers.
Sasha, may I just shortly interrupt because I can almost not hear you sometimes. If you could approach the microphone closer or speak a bit louder, because
okay.
the voice is fading away. Sorry.
Then I'll try to speak louder. Of course, Tim and Ray are not alone in this approach, and probably there is a good example of convergence we will be discussing later. Theoretical and methodological grounds for introducing information theoretical approaches into the discipline were actively discussed in the recent absolutely great volume defining and measuring diversity in archaeology. Several papers, including Jonathan Page's and Charles Perrot's recent one. The interesting thing about is that the first attempt to introduce information theory into archaeology was conducted as early as in 1973, but for some reasons this paper of Justerson didn't attract attention it deserves. And perhaps this is something we should also keep in mind when thinking about cultural evolution. Let us now turn to quantifying diversity, tools from information theory. Applications of various diversity indexes or entropies are quite common in archaeological research because the most widely spread diversity index is the Shannon diversity index or the Shannon entropy. Here is a very short list of examples of this of its applications. So basically, it's estimated as a sum of proportions of cultural traits of a certain belonging to certain units multiplied by the logarithm of these proportions. Let me explain this a bit more using a hypothetical example. Let us assume a set of artifact types, including three artifact types A, B, and C, with the proportions distributed as 0.8, 0.1, and 0.1. We add a new type to this set, type D, in very low proportion, simultaneously decreasing the proportion of type C. So a new type is added, diversity slightly increases. However, if we do not introduce any new type, but just change proportions, meaning reducing proportion of A type cultural traits to 0.6 and respectively increasing proportions of the other two types, the increase in diversity is significantly higher. And the maximal diversity, also known as the maximal values of the diversity index, also known as maximal entropy or Hartley entropy, is reached when the proportions of all types are distributed evenly. Many of us might have an impression that they were doing something like that, and this is the absolutely correct impression, because to an extent, diversity indexes is just another way to represent proportions we estimate doing frequency variations when construct relative chronologies. So when the proportion of a certain cultural trait increases, diversity decreases, and vice versa. And that is something we see in patterns. For example, the case cited above, Western Tripoli culture, pottery shapes this rise and fall in diversity. Besides adding and dropping out pottery types in terms of frequencies, it is represented by the replacement of spheroconical vessels by biconical vessels, replacement of craters by crater-shaped vessels, and decreasing proportion of goblets and increasing proportion of goblet-shaped vessels. In both cases, looking at the LBK and Western Tripolia data, we kind of were putting cultural traits into boxes, while archaeological categorization is rather about putting things on shelves. And this is the case where non-Shannon entropies are useful. More specifically, Renyi entropy is a good example. Besides, it generalizes Shannon and Hartley entropies. It also accounts hierarchical structure of data we analyze. Ray and team actively develop their work on non-Shannon entropies, which is important to admit. So basically, what's going on is when levels of taxonomic hierarchies created by archaeologists decreased, entropy increases, and vice versa. More recent studies, including several chapters in the book cited above, and recent studies by Ray team and their collaborators argue that entropies are not diversities, but diversity indexes. And to achieve real diversity, we should exponentiate entropies. There is a solid argumentation for this and lots of mathematical solutions to a number of uh, archaeological problems. What is interesting to note in respect to convergence we will be discussing further is that Ray and team developed this approach independently from the authors of the cited uh, diversity volume. And the trick is common ancestry. So all the experts considered ecological approaches to the diversity of species. Let us now take a look at drivers of diversity. The easiest way to do this is modeling diversity patterns. Perhaps one of the most simple ones would be a good starting point. I mean the rise and fall patterns in the diversity of styles which do not reflect socio-economic shifts. I will not bother you with mathematics, instead briefly explain model inputs and outputs. So, as we discussed a few minutes ago, there is the frequency dependent different impact of cultural traits on on the overall diversity of archaeological assemblage, and we should account this in simulations. Such a discrimination of the less frequent artifacts may sound a little bit strange, but consider the fact that we do it for dozens years, discussing global amphora or funnel beaker cultures and so on. Mathematically, the model integrates Rene entropy, which is borrowed from Ray Rivers' work. This is done in order to consider archaeological taxonomies and discrete version of the logistic equation. The latter is considered in order to account more or less gradual replacement of styles and discrete time units we usually deal with in archaeology in the form of phases, periods, and so on. The trick with logistic map is uh, its chaotic properties, in our case, leading to the singularities in the model equations. Of course, using the term singularity, I do not refer to science fiction. Instead, just refer to the term which describes system behavior reaching a point when the model equations break down. So, getting back to the discrete version of the logistic equation, its behavior is completely controlled by the parameter R, which is in our case replication rate of cultural traits. When R is high enough, the model falls in this singularity, meaning the proportion of cultural trait significantly increases and then drops. Moreover, it drops to such a low point that the sum of uh, cultural traits referred to blue and red types doesn't reach 1. And in this way, This singularity is interpreted as a phase of openness for innovations in cultural sets. Just a brief reminder that innovation is treated as socially accepted invention. So cultural set may be contributed by local innovations or borrowed from elsewhere, from the neighbors. So in terms of theoretical understanding, such interpretation of singularity fits quite well what is done by a number of scholars doing technology, science, and lots of such examples of significant increase of some traits followed by the rapid fall are provided by Alexander Bentley, Michael O'Brien, and Mark Earls. My favorite example for this is the playlist on your computer. Imagine you are enjoying some new song, playing it again and again and again, increasing rates of playing this way. But suddenly you just get boring of it, it drops and being replaced by some other tracks. So getting to model outcomes. Since the model behavior is controlled by the ratio of the artifact's replication rate and the proportion of traits of the related unit of the higher taxonomic level, diversity drivers are population size and structure, duration of the analyzed phenomena, and the artifact's use life, which finds very good agreement with the significant number of empirical studies and outcomes of the other models. Moreover, model expectedly shows scale-dependent dynamics because of integrating Renee's entropy into it. The dynamics increases with the decreasing taxonomic level. As you can see, you may consider some hypothetical types and get just one cycle or rise and fall in diversity pattern, which corresponds to the two such cycles when dealing with variance, meaning cultural traits of the low level of taxonomic hierarchy, which leads to the conclusion about gradual evolution at the low taxonomic levels and its punctuated character at the high taxonomic levels. Besides this, model outcomes include scale-dependent innovation flow. There is a widely known paper by Erkens and Lipo showing the importance of open errors as sources of possible inventions, which are in turn sources of possible innovations. The difference is that Erkens and Lipo worked with variation in continuous traits and to make the results comparable with the outcomes of our model, we should transfer this variation into units in discrete traits. So copying errors decrease with decrease in taxonomic level, and therefore there is a higher probability for horizontal transmission at the low taxonomic levels and lower probability for vertical transmission at the low taxonomic levels. I'm just reminding you that this goes only about styles, but not about functional. Since, however, as archaeologists, we know lots of uh, examples for this. For, for instance, published in this exciting volume edited by Peter Beale and Yuri Rosamakin, Import and Imitation in Archaeology. So let's leave a space of styles and enter a broader area and discuss convergence and transmission scale. Evolution takes two passes, which are divergence and convergence. The first one refers to a common ancestor in traits, while convergence describes the evolving of structures that are similar but not related to a common ancestor. I would like to admit a really exciting volume on convergent evolution in stone tool technology, edited by Michael O'Brien and his colleagues. What is interesting that convergence in archaeology is mainly considered by the experts in the stone tool technology. But even in this book, almost every single chapter underlines that convergence in archaeological research and convergence in stone tool technology is underestimated, and diffusionist approaches dominate even if they are not grounded well. Thinking of convergence, Ivona Ray and I decided to take a closer look at emergent technological complexity. And the starting point for this work was Brian Arthur's model of the evolution of technology. Arthur defines technology through its properties. Technology originates as a new concept and develops by modifying its internal parts, comes to be in around certain phenomena and develops by changing its parts and practices, and originates from the use of natural phenomena and builds up with the new building blocks formed by combination from old one. In other words, innovation for Brian Arthur is in many ways a recombination of existing component parts, which are also technologies. This book is widely known and widely used in archaeological research dealing with technology, so our study comes in line with numerous other papers. On the other hand, the requirements for convergence are quite simpler. These are the similar purposes, availability of the component parts in a culture, and specific connectedness of these component parts. So all you have to do to achieve independent innovation and development of a technology is recombine what you already have. Of course, if uh, the if similar purposes and availability are both in place. Of course, different technologies have different complexities, are characterized by different degrees of complexity. And the likelihood of convergent evolution of a particular technology increases with the decrease of this technology internal diversity. This is something widely discussed by, for example, Valentin Ruth, Stephen Shannon, other scholars. The only question is measuring technological complexity. And in this case, again, studies in stone tools provide us with a solid ground for further research. Well, in particular, I would underline the most recent paper by Page and Perot, who used information-theoretic tools, including joint entropies and conditional entropies, working with complexity of stone tools. We developed a new approach to it, also borrowing tools from information theory. Again, I will not bother you with the mathematics, but briefly explain what was done. So we introduced conditional diversities in order to account connecting component parts, joint diversities in order to account overall technological complexity, and a new element is technological impact factor. The greater the reduction, the larger this factor is. And this technological impact factor is a very good tool for identification of the most important component parts of technologies. So Ray, who is not only a brilliant scholar, but an expert in great metaphors, provide the following for this case. Imagine small horses and big horses driving chariots. Of course, big horses could move either small chariots or big chariots, while small horses move only small chariots. This means that the technological impact factor for the later case is greater than the impact factor for the former case. And this means that as soon as you replace all your big horses by small horses for whatever reason, for instance, because they eat less or whatever else, the further evolving of your technology is quite understandable and predictable. This brings us to the conclusion that there is no need to borrow technology as a whole. Borrowing important component parts, which are themselves technologies, meaning that you may borrow these component parts for completely different reasons, but once you have it in your culture, it is absolutely enough for being recombined in a while. In other words, transmission scales and the ground for convergence are the important component parts, not necessarily the technologies as a whole. In theoretical respect, we would agree with the editors of the exciting volume on stone tools, convergent evolution. We significantly underestimate it in archaeology. Of course, when we have such examples as painted pottery, pyramids, or origin of agriculture in the old world, and new world separated by significant distances and significant chronological gaps, we have no problem to consider and to accept convergent evolution. But why doesn't it work at chronologically and spatially narrow frameworks? Perhaps it should, and to confirm this, the best way to analyze convergent evolution is applying phylogenetic approaches for archaeological data, maybe contributed with the outcomes of our study indicating technologically important component parts. So finally, what is it all for? Is anthropology, as suggested by Ray and team, a kind of a pathway towards a new synthesis in archaeological theory? The usefulness of mathematical tools borrowed from information theory doesn't raise an equation. But what about theoretical components of our discipline? In my view, information theory may serve for an interpretive component of archaeological theory, providing a space basically for everybody. Those interested in data categorization, taxonomies, data aggregation, mathematical methods, including modeling, interaction, communication, networks, complexity in archaeology, and more would find their places in this highly interconnected theoretical world. Moreover, it might be a way to balancing archaeological evidence with data from other fields of scientific data in terms of Kristian Kristiansen. Finally, anthropology is a path to understand human culture and therefore human nature. Last but not least, as you noted, a part of this research was done in collaboration with Sergei Ryzhov, who unfortunately left us last year, and this talk is dedicated to this outstanding scholar and outstanding person. Thank you very much for your attention.
Thank you, Sasha, very much for your presentation, rich in ideas and in theoretical input.